Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shazani binti Muhammad Saimi and I'll be present about the journey of ceramic to polymers. So first we have to know what is ceramic and what is polymer. Ceramic is a hard material that is held together by a unique and covalent bond, while polymer is a material with very large molecules that form from repeating monomers, and those monomers are held together by covalent bond. So since both materials are made up from covalent bond, so we can use laser welding method to join them together. Specifically for polymer, we will use laser transmission welding. It is a type of fusion welding process where two pieces of materials, either similar or dissimilar, are joined together by the use of laser. The laser beam provides a concentrated heat source that focuses to the cavity between the two materials that will be joined. This table shows the advantages and disadvantages of the laser transmission welding. Some of the applications that use laser transmission welding are battery welding, bioimplantable sensors, automotive components, and microfluidic devices. Uh, this is the basic fundamental of this method. We can see here laser beam, uh, ceramic substrate, polymer substrate, and also external pressure, or also known as clamping force. In this laser transmission welding, we consist of two types of substrate, the top and the bottom substrate. The top substrate must be laser absorbing, while the bottom substrate must be lower absorbent or laser absorbing to the laser radiation. And we want to make sure that the bottom laser absorbing substrate can undergo localized melting at the interface. So when the laser beam penetrates through the top transparent ceramic part or transparent laser transparent part, the portion of the laser beam that is not reflected will be absorbed by the polymer parts. It will propagate and gradually transfer the energy in the form of heat. And the heat produced in the material can melt the interface of the substrate, thus the joining between both substrates will occur. These are the parameters that should be considered during laser transmission welding: laser intensity, laser power, travel speed, stand-off distance, welding temperature, exposure time, and pressure applied. Here are the common issues of joining the materials using this kind of method. First, the melts of the two successive spots tend to mix together when the cooling time is insufficient. So the bubbles will form and the melt can expand volumetrically. So the melt material can move to the opposite areas. So we have to need a delay time to avoid the mixing of spot melt poles. Second one is the excess of carbon dioxide. Laser can cause fracture cracking due to introduction of thermal stress on ceramic substrate. High laser power of carbon dioxide with short exposure time can lead to fracture cracking of ceramic, and this crack can cause the weld to penetrate through the polymer with low strength. And the third one is over-applied clamping force can also induce crack on the ceramic part. The clamping force basically is used to clamp together the polymer and ceramic substrate in order to maintain the enough contact between both parts and also to avoid slippage. However, since ceramic is a brittle material, it is hard to make sure that the clamping force applied is sufficient enough and not deform the ceramic part. The fourth one or the last one is overheating. It is relating with slow welding speed. that cause the interaction or contact time between ceramic polymer parts and the laser beam become longer. So the high temperature applied during this process can cause polymer decomposition, bubble formation and long cavity formation at the joint center, which can weaken the joint sign that just occurred. So for the current trend, by using this laser transmission welding, we can see in a medical field where laser welding has become the technology of choice for joining ceramic polymer in today's highly advanced technologies such as wearables, microfluidics, complex cardiac devices, steroid kits, implants, tissue engineering technologies, and many more medical applications. And the contaminants or particles that could harm delicate structures and affect device performance have a low tolerance in all of these devices. That's why laser welding has been proven to be a method that can help to achieve this kind of purity. So these are the recommendations to improve the joining based on the common issues that have been mentioned before. First, use the right combination of laser parameters. There are a lot of laser parameters, so we have to make sure that the combination of the value is right in order to get a better weld or better joint of the substrate. Second one is the design of the clamp part is not too highly affected. The clamping material means we have to consider the clamp size, shapes, and also the clamping material itself before before operating the laser transmission welding process. Third one is properly choose the materials that can be joined by laser welding by analyzing the properties and characteristics, especially the brittleness and the ductility of a certain material. And lastly, give adequate time for cooling process to avoid the formation of a bubble that can reduce the strength of the joint. So that's all from me. Thank you and Assalamualaikum.